Now let's look at equations in a different form, but see if we can still use this idea of slope-intercept. So I have an equation in standard form. And before we would do y-intercepts and x-intercepts, that would be helpful. But in this particular one, it goes to the origin, so that's not as helpful as it could be. So let's give this slope-intercept form a chance, which means let's solve it for y. Divide both sides by 5. And now we have an equation in slope-intercept form, although my y-intercept is 0, which is what I would have expected. So from here, what can we do? Well, let's draw our grid. We know what our y-intercept is. It's 0. So our starting point, what we're going to kind of base the rest of our graph off, is right here. And then we could look at its slope. I know this is its slope because it's written in y equals mx plus b form, and that coefficient is its slope. So I have a slope of -2 and 5. So the -2 tells me my rise. In this particular case, my rise is down 2 and then over 5. And there's the graph of 2x plus 5y equals 0. It is also worth mentioning at this point right now. I had my slope, which is a -2 over 5, but that's also equivalent to 2 over a -5. Well, if those are the same, then would I get a different second point and a different line? Well, let's look at this. All right, my 2 tells me my rise, so I go up 2, and then the -5 tells me I go backwards 5. And that's also on the line, but in the other direction. So when I found the slope, first time I found the one that's farther to the right, my next point, but I could have also found the point that preceded it. Again, all those points would have been on the same line. It's all good. So when you look at slope, it doesn't matter if the negative is on the numerator or the denominator. You're still getting 2 points on that line.